Hello and welcome to the Product Development Webinar Series. This series is designed to help you learn how to solve some of today's toughest product design challenges. My name is John Gaioni, and joining me today is my colleague Kyle Aruda. We're both from Siemens PLM Software. Thank you for joining us today. Now today we're going to talk about successful product redesign and how to leverage existing product designs efficiently. But as a part of this series, we're going to look at related issues around product development. There's a variety of other on-demand webinars, some of which are listed here. Be sure to catch those. Please feel free to enter your questions at any time during this presentation. We'll get to them during the Q&A session at the end of the webinar. With all that said, let me give you a better idea of what we're going to cover today. First, I'll describe the nature of reuse and the challenges of reusing product design. Next, we'll look at the implications of these challenges to both you and your organization. After that, we're going to look at how one company sought out and applied Next Generation CAD and the impact it had on him and his company. With all that said, let's get going. Time is money. Time saved in the design process can improve on the quality of the designs and allows more time to cultivate new business opportunities. These activities are valuable as they bring merit to the organization and its customers. As we all know, engineering is a big job. Engineers have huge responsibilities at every stage throughout the product lifecycle. Dedication is required to achieve better designs. The job is challenging, but can be very rewarding, given the right tools and process to encourage excellence. Let's talk about reuse. Why reuse? Because reuse makes good sense from the business perspective as well as from the productivity perspective. Business demands the reuse of product. Productivity demands the reuse of design. Let's then examine the benefits from both perspectives. Being able to reuse the original product design gives a business a competitive edge over the competition. Popular products can stay on the market longer as obsolete parts can easily be replaced with new ones. Product offerings can be broadened as variations of the same product can be made available to increase choices for the customer. Bringing a new variant of the product to market is quicker when the product is reusable. From the productivity perspective, it is the ability to reuse an existing design that makes the job of an engineer easier. It saves time as the engineer is able to reuse the existing design and only change the necessary parts to bring the design up to date. It is this advantage that is the time saver. It also minimizes risk since the existing design will most surely have been proven. Let us quickly examine a sample bill of materials of a product identified for reuse with its change requirements and the associated action performed in CAD. The requirements for changes in a product parts can be due to various factors as seen in the illustration here. It can be for cost reduction in assembly, or an upgraded function, or because a new supplier is being identified to supply the part which requires a slightly modified fit, or due to the end of life of a part from an existing supplier. All these requirements will be translated into actions needed to be taken on in the CAD platform, such as creating a new model or modifying from an existing one or an entirely new model in some cases. There are many challenges in traditional CAD in supporting reuse of designs. There are two key challenges: the added time it takes to make revisions, and the difficulty editing imported models from other formats. These challenges can hinder productivity and business competitiveness. Before I turn it over to Kyle, I'd like to pause for a minute to reflect on the information that we've presented thus far. The question I have for you is this: what is the most significant challenge impacting the way you design and develop your products? Is it 1, I spend too much time making revisions? 2, it's difficult to edit imported models? 3, my current CAD reuse function is slow? Or all the above? Now I'm going to turn it over to Kyle, and he's going to take a deeper look at product reuse.
Thanks, John. You know, the ideal reuse scenario would be, one, retrieve the model, make the design change, and this can be done by any designer. And third, the required changes are executed successfully in a very short amount of time. Now, in contrast, the reuse scenario of a traditional CAD system would mostly look like, hitting a roadblock when you came to step number 3. Failure to successfully execute changes on common problems in traditional CAD due to the nature of the history-based modeling methodology. The dependencies of each part in the model makes it difficult to alter a part without affecting the functionality of the other parts. So to fix the failure, more resources are required. There needs to be involved the original designer, to call upon CAD experts, and of course, time to require to investigate the failure and know where and what to fix. And when all efforts fail, the next step is to rebuild the model from scratch. And rebuilding takes a whole lot more time and causes delay in product launches and takes up valuable time of engineers, leading to personal sacrifices. And if these are not addressed quickly, the implications to both the organization and the engineer can be dire. So what does this actually mean? Your designers will most likely spend an enormous amount of non-value added time trying to fix the reuse issue, quickly reaching the reuse tipping point. And in the end, it might actually be quicker, like we said before, to recreate rather than trying to modify the existing design. So we wonder, is it faster to fix an existing model or to rebuild? CAD should really enable reuse efforts. It should not hinder them. And it should be a tool that will enhance the capability of the designer. And the Next Generation CAD enables reuse of designs. There are clear benefits for the organization and engineers. Some of these benefits are listed here. Changes can be made by anyone. Minimum expertise needed. Projects can be completed on schedule. And being able to leverage on existing design saves time and money. And engineers are free to design and not investigating failures. Everyone is happier with less stress to meet their deadlines. Let's take a look at a case from Kimball International. Kimball International is one of the most recognized wood office furniture manufacturers in the Americas that has successfully implemented several engineering specifications and documentation systems in 3D modeling, PLM, and simulation. As with many design companies, Kimball's journey in CAD is not without challenges. One of Kimball's many challenges is the difficulty in reusing existing models. Reusing has always ended up having to be fixed broken features, causing valuable loss of time, and the process is also very time and labor intensive. Efforts from old designs are often wasted due to the difficulty of reusing them, leading to recreating them from scratch. And recreating then leads to delays in the project completion. All these challenges amount to the loss of valuable time, which then is equated to the loss of revenue for Kimball. Kimball realized that they needed to make a change in their existing CAD to the Next Generation CAD, which better supports reuse. In this example, Kimball needed to make a slight modification to a 15-year-old design that is in still high demand in their market. So these are the situations. Marketing wants to create a metal version of some of the drawer units as seen in the illustration. Existing CAD data is in an IGES format, a format that is non-native to the current CAD Kimball is using, and engineering resources and development time are conflicting. So we're going to take a look at a comparison on the total time taken to do a similar activity in both traditional CAD and the Next Generation CAD. This slide shows a total of 7 hours and 10 minutes and a series of activities involving planning and executing the reuse of the design used by traditional CAD. So using the Next Generation CAD, Kimball is able to reduce the total time taken down to 1 hour and 10 minutes for the same activity. And one of the key benefits of the Next Generation CAD is that it completely eliminates the time needed to learn, validate, and fix errors, which are often present in reusing parts using traditional CAD. In traditional CAD, changes are made at the individual parts in isolation, making it difficult to adjust changes required for related parts. In contrast, using Next Generation CAD, the designer is able to make changes at the assembly level. This allows for direct manipulation of parts within the assembly, and any changes to related parts are then automatically adjusted by the CAD system. And this creates an error-free environment for the designer to work with and make changes a whole lot easier. So as you can see, switching to Next Generation CAD increased Kimball's competitive edge by being able to work faster. And the case shown, gone from 7 hours down to just 1 hour. The ease of reuse saves valuable time, and 85% is illustrated in Kimball's case. And again, Kimball is able to do this because of the Next Generation CAD. Hey John, what is the Next Generation CAD?
Solid Edge with synchronous technology is Next Generation CAD. With Solid Edge, there are minimal interdependencies. With minimal dependencies, there are minimal failures. And furthermore, there aren't feature failures because they just don't exist. Overall, there are far fewer constraints when an engineer wants to experiment with the design, and that means flexibility in the design process, making reusing design just that much easier. With Solid Edge, you can do more in less time. Making changes to design is a breeze, and everything happens in real time. The flexibility of Solid Edge allows you to design faster and easier. Solid Edge is the Next Generation CAD that will make a difference in the way that you design. Here's what our customer, Kimball International, has to say.
My name is Ricardo Espinosa. I work for Kimball International in Jasper, Indiana, and my title is R&D Engineering Services Manager. We have three main divisions: National Office Furniture, Kimball Office, and Kimball Hospitality. Office furniture has been changing a lot in the last years. Open spaces, interaction, networking, using technology, communications technology. So we are redesigning all the furniture that everybody uses to meet that new conditions. Our products, even though they're unique, they share a lot of components. We build the same desk for different models with same features, but depends on the order that we put these features, the final result is completely different. When you work with a traditional CAD system, it's very slow to create all these little modifications. With synchronous technology, we learn that you can create a basic model, and then without doing additional calculations, without even knowing the dimensions of the final components, you can just edit this existing parts and create something new. We have chair. The same basic chair goes to 4 or 5 different uses, like a bariatric chair. The same chair could be used in a hospital, could be used as a visit chair in an office, or could be a reception chair. And there's some important modifications in dimensions. It could be wider, taller, the materials that you use are different. If you have to open a traditional CAD model and change those dimensions, it takes hours. With synchronous technology, we can do in minutes what we used to do in hours. This chair have probably 70-something different configurations, and we can create all the documentation, including drawings, for all these 78 configurations in probably a couple hours, versus probably 3-4 days in the past. We have old products that are still in the market, especially on the traditional products. We have chairs that have been in the market for 50 years. Now, we are adapting those chairs for cost reduction, for new markets. In the past, it was very difficult because we had to start from scratch. Now we're using this legacy information that came from the 90s, the 80s in ideas, and with synchronous technology, it's really easy to reuse this existing information and create new components. Bringing components or assemblies from ideas to solid edge synchronous technology takes only a few minutes. The main reason we're doing this is to be more productive, do better products, get faster to the market, and have fun.
As you can see, Solid Edge gives Ricardo and Kimball International a huge edge over their competition by allowing for quick and easy reuse of design. What you are seeing here is real product. These are new products modified from the existing original design using the Next Generation CAD, Solid Edge with synchronous technology. CAD should support ease of design reuse and allow designers to effectively make changes based on existing designs and not waste time being an expert in CAD. Having seen all the things that Solid Edge can do for you, you should want to revisit your design process to see if there is a need to be better. We shouldn't underestimate the inability to reuse existing designs. And why is that important? Because the implications of unable to reuse can be costly. Solid Edge enables better reuse of designs. It is the Next Generation CAD. It's faster, cost-effective, and competitive. Kimball International is a testament to consistently achieving significant ROI by designing their products with Solid Edge. You've heard Solid Edge mentioned throughout this session, but have not formally introduced it. So let's wrap up the session with a quick overview of Solid Edge. Solid Edge is a complete 3D design and engineering solution that transforms ideas into great products and gets them to market now. Using synchronous technology accelerates equipment design, speeds revisions, and improves the reuse of previous designs. Solid Edge simulation for digital validation of critical components reduces the need to create physical prototypes, lowers material and testing costs, and improves reliability. Solid Edge manufacturing for definition of accurate machining, fabrication, and assembly processes improves overall manufacturing efficiency. Solid Edge Design Management improves the overall efficiency of equipment design projects and ensures that accurate product data, specifications, and requirement documents are available to all. And a growing app ecosystem. Solid Edge apps extend the capabilities of Solid Edge to provide a complete ecosystem for product development and manufacturing that meets the needs of today's manufacturing organizations. There's a vast array of applications, from process plant to design to tools and utilities, for rapid, high-quality product development and functionalities related to design and engineering. Solid Edge with synchronous technology is the answer to bring your design process and organization to the next level of effectiveness and profitability. It will make a difference in your business. You will see your products to market faster. But don't just take my word for it. Take the next step by test driving Solid Edge today with our free 45-day online trial. Now you can try a fully loaded version of Solid Edge free with no obligation. Discover how Solid Edge provides the speed and simplicity of direct modeling with the flexibility and control of parametric design, all in one easy-to-use package. Try Solid Edge for free. The URL is listed right here on the slide. On behalf of Kyle and myself, we'd like to thank you. We know your time is valuable. We appreciate you joining us today. Solid Edge, design better.